For all of human history, we've been shielded, cradled by a planetary magnetic field and a thick atmosphere. We've lived our entire existence completely protected from the true nature of the cosmos. But we are about to leave that cradle. And what's waiting for us on the other side is an environment more hostile and unforgiving than we can really comprehend. This isn't science fiction anymore. The missions are being planned, the rockets are being built, and for the first time, we are facing the terrifying reality of deep space. For decades, going to Mars or the outer planets was a distant dream, something for Hollywood blockbusters, but that dream is rapidly turning into a very real engineering problem. Programs like NASA's Artemis aren't just about returning to the moon. They're a critical stepping stone, a dress rehearsal for the enormous leap to Mars. This new era of exploration is defined by a terrifying truth. The very same technologies that will carry us into deep space must also keep us alive against a constant barrage of lethal hazards. We're finally building the ships, but in doing so, we're forced to confront the monumental dangers they have to overcome. The journey to becoming a multiplanetary species isn't just about discovery, it's about survival. The single greatest threat to human life in deep space is something you can't see, hear, or feel until it's too late. It's radiation. Here on Earth, we're almost completely protected from it. But once you leave low Earth orbit, you enter a cosmic shooting gallery. Just one day in space can expose an astronaut to as much radiation as you'd get in an entire year on Earth. There are two main culprits. First, you have solar particle events, or SPEs. These are violent, unpredictable eruptions from our own sun that blast torrents of protons into space. An unprotected astronaut caught in a major SPE could receive a lethal dose of radiation in a matter of hours. But the more persistent, more insidious threat comes from galactic cosmic rays, or GCRs. These are the remnants of distant supernovas, atomic nuclei stripped of their electrons and accelerated to nearly the speed of light. They are particles of immense energy that slice right through conventional shielding like aluminum and, more importantly, through human tissue. They don't just pass through, they're like atomic-scale cannonballs shattering everything in their path. This relentless bombardment shreds DNA, massively increasing the lifetime risk of cancer, and causes degenerative damage to the central nervous system, heart, and eyes. Studies show this sustained exposure can lead to cognitive decline, memory loss, and behavioral changes. A terrifying thought for a small crew relying on each other for survival millions of miles from home. So how do you build a shield against something so powerful? This is where science is our only defense, and it's a problem being tackled with incredible innovation. Researchers are moving beyond simple metal plates and exploring advanced materials. One promising idea is using hydrogen-rich materials like special plastics or even water itself. Water and materials like polyethylene are effective because their hydrogen atoms are great at absorbing energy from GCR particles. Teams at Ghent University are even developing 3D printable hydrogels, super-absorbent polymers that can hold huge amounts of water in a stable, solid form, creating a practical and effective shield. Beyond that, scientists are looking at active shielding. This is the sci-fi dream of generating powerful magnetic fields around a spacecraft to create an artificial magnetosphere, deflecting radiation just like Earth's magnetic field does. While still in early development, combining advanced materials with active shielding represents our best hope of surviving the invisible storm of deep space. Radiation isn't the only thing trying to kill you out there. The cosmos is also a minefield of micrometeoroids and orbital debris. People think of space as empty, but it's more like a desert filled with invisible hypervelocity bullets. A micrometeoroid can be smaller than a grain of sand, but it can be traveling at over 22,000 miles per hour. At that speed, even a paint chip has enough energy to cause catastrophic damage. For decades, our main defense has been the Whipple shield, a deceptively simple but brilliant invention. It's a thin outer layer of material held a short distance from the main spacecraft wall. When a micrometeoroid hits this sacrificial layer, it doesn't just stop it, it shatters it. The impact vaporizes the particle and the shield, spreading the energy out into a wider, less focused cloud. This cloud then hits the main wall, but with its energy dissipated, it prevents a fatal puncture. Today, this concept is getting a major upgrade. Instead of just aluminum, modern shields use advanced fabrics like Kevlar and high-strength composites. For its inflatable life habitat, Sierra Space has been conducting hypervelocity impact tests at NASA facilities, firing projectiles at nearly 7 kilometers per second to simulate orbital debris. They're using Vectron, a chemically woven fabric, to create flexible, lightweight, and durable shielding, but shielding is only half the battle. You also have to see the threat coming. Advanced sensors and laser ranging systems are being developed to track and map space debris with incredible precision. This data can then be fed into AI-driven navigation systems, allowing a spacecraft to autonomously plot the safest course through a debris field, dodging potential collisions in real time. This combination of tougher shields and smarter avoidance systems is what will let future missions navigate the cosmic gauntlet. One of the biggest hurdles for deep space travel is the sheer length of the journey. A trip to Mars with conventional chemical rockets takes 7 to 9 months one way. That's a long time to be stuck in a can, soaking in cosmic radiation and dealing with the psychological strain of being so far from home. The faster you can get there, the safer the mission is. That's why a revolution in propulsion isn't just a convenience, it's a necessity. The most promising leap forward is nuclear thermal propulsion, or NTP. An NTP engine uses a compact nuclear reactor to heat a propellant like liquid hydrogen to insane temperatures and expel it through a nozzle. This is up to 3 times more efficient than today's chemical rockets. A Mars mission with NTP could cut the travel time to just 4 or 5 months. NASA and DARPA have been working on this through the Draco program, but the planned in-space test has been put on hold due to challenges with ground testing the nuclear reactor. The other game changer is in-orbit refueling. A rocket leaving Earth uses most of its fuel just to escape our planet's gravity. SpaceX is tackling this head-on with Starship. The plan is to launch the main Starship and then send up multiple tanker Starships to meet it in low Earth orbit and fill its tanks. This is so critical that NASA considers it essential for future missions to the Moon and Mars. SpaceX is planning a ship-to-ship propellant transfer demonstration for 2025. This would crack open the ability to move massive amounts of cargo across the solar system, making these ambitious missions possible for the first time. Together, Nuclear propulsion and orbital refueling are what will finally break the tyranny of distance. Even if we can protect a ship from space, we still have to protect the most complex and fragile part of any mission, the human mind. Long trips in space take a heavy toll. We all know about the physical effects like bone density loss and muscle atrophy, but the psychological challenges are immense. Future Mars crews will have to live together in a space about the size of a studio apartment for up to 2.5 years. The isolation is profound, and as they get farther away, communication with Earth will no longer be instant. A message to Mars can take over 20 minutes to get there, making real-time conversation impossible. That delay eliminates any chance of immediate psychological support from Earth during a crisis. The combined stress of confinement, isolation, and constant danger can lead to anxiety, depression, and conflict, all of which could doom a mission. NASA and its partners are tackling this head-on. Astronauts go through extensive training in teamwork, conflict resolution, and self-care. For future missions, research is underway to develop autonomous mental health support systems using AI and VR to provide confidential counseling and stress management tools when Earth is too far away to help. These systems, along with mindfulness and relaxation techniques taught before the mission, are designed to build resilience and give astronauts the tools they need to manage their own well-being. Protecting the mind is just as critical as protecting the body. We have to solve this to make sure the astronauts who arrive on Mars are not just alive, but are ready for the challenges of a new world. The path to deep space isn't a fantasy anymore. It's being built right now, in labs, on test stands, and in the skies above us. Missions like Artemis are laying the groundwork, testing the systems and pushing the limits of what we thought was possible. We're creating shields to stop invisible radiation, armor to withstand hypervelocity impacts, engines to conquer cosmic distances, and support systems to sustain the human spirit. Each of these challenges is terrifying. The dangers are real and the stakes couldn't be higher, but for the first time in history, the solutions are also becoming real. The technology is tangible. We are standing on the edge of a new shore, looking out at a vast, hostile ocean. The journey will be the most difficult and dangerous thing humanity has ever tried to do. But we are finally building the ships to make that voyage. The terrifying reality is we're going. Exploring this new frontier is one of the greatest challenges of our time, and the innovations that get us there will change the world. If you want to follow this incredible journey, make sure to subscribe and hit that notification bell. And for a closer look at the rocket technology making it all possible, check out our video on nuclear thermal propulsion right here. Thanks for watching.